Hi students, today we are going to discuss the past year paper STPM 2016 section A. So let us go through together the question number 1. So the solution is prepared by dissolving 14.9 grams of HCl in water. So when excess silver nitrate solution is added to solution, 28.7 grams of silver chloride precipitate is formed. What is the reaction? The equation where the reaction between HCl here together with the silver nitrate. Okay, so like this: HCl plus Ag nitrate. Okay, so become XNO3 plus AgCl. Okay, so this will be the reaction. So initially, the question given us the mass involved for the HCl will be 4.9. Okay, then the final, given that the silver chloride precipitate form will be about 28.7. Okay, so we have to see what is the numbers of mole involved. Okay, so firstly, so we have to find the X, what is the atomic mass. But here we know here is the silver chloride. So the relative mass for the AgCl will be 108 plus 35.5. So you'll get 143.5 grams. So numbers of mole for silver chloride here will be 28.7 divide atomic mass. So we get will be 0.2 mole. So here 0.2 mole of the silver chloride will be formed. Okay, so according to this equation, so the 0.2 mole silver chloride form is actually also the same as 0.2 mole for the HCl will be used here. Okay, so we know that the numbers of mole equal to mass divide the molecular mass for the HCl, mR here. So here 0.2, mass used will be 14.9. Then we get relative mass 14.9 divide 0.2, 74.5. Okay, so this one is for the HCl. So for X, we need to minus 35.5, which is the atomic mass for the Cl. So we left X. So answer 39. So B. Okay, then we go to number 2. So iodine 123 is used in brain imaging, and iodine 131 is used in detecting the activity of thyroid. Both isotope. So which one is the correct answer here? Okay, so according to here, 131 and 123, we're using the radioactive ray, right? Gamma ray, for example. So that means here we need to have the radioactive decay process here, so that the gamma ray will be emitted. So that means the process here will be unstable lah. So the isotope here will be unstable. So the A is wrong already. Okay, and then the second one, so the crystal have different crystal structure. So the crystal structure is not depends on the type of isotope. So the answer will be also out for this. Okay, then C, react with the aqueous solution of Ki. Okay, so both isotope actually had the same chemical reaction. Okay, so here both actually is I2 lah. So I2 will be react with Ki and then produce K positive and I3 negative. So this will be the answer lah. And then the D, we sure that this will be wrong also lah, because the isotope they have the same numbers of proton but different numbers of neutron. Okay, so here should be same numbers of proton lah. So wrong already. Last answer will be C. Okay, then the next, number 3. Okay, so the first 4 line of Lyman series of the hydrogen spectrum is known in the diagram. Okay, so we know that the Lyman series will be n from infinity will be dropped to n equal to 1. Okay, and then the Lyman series also at the region of UV region now. Okay. Okay, so the first one, what could be deduced based on the Lyman series above? The continent of the Raman series appear after line number 4. So as we know that from this figure here, so see, you can see the line is merging at 4, number 4 here. So that means the frequency actually keep increasing. Okay. Okay, so the Lyman series considered as the highest energy series lah. So that means the Raman series actually are here. Raman series will be here. Okay, so here will be Raman series. So that means that the statement A is wrong already lah, because the Raman series is actually before line 1. Before line 1. Okay, then line number 4 is due to the electronic transition from n number 5 to number 1. Okay, so for first line here, appear as when n equal to 2 to n equal to 1. So we will appear this line. For this one will be n equal to 3 to n equal to 1, right? Then here, n equal to 4 to n equal to 1. This line will be n equal to 5 to n equal to 1. So that means answer B is correct already lah. Okay, and then the line number 3 for C. So line number 3 is due to the lower frequency of the line than that of the line 2. So according to our explanation just now, the frequency will be increased from 1 to number 4. So that means that the line number 3 will be have higher frequency compared to line number 2. So the statement here also wrong already, to be higher lah. Okay, and then D, the series of the line appear in visible light region. So here will be also wrong already lah, because the visible light region referring to Raman series. So here the Lyman series referring to UV region lah. So here is wrong already. Okay, so answer is B for number 3. Okay, so we go for question number 4. The following valence configuration are for atoms that form ion with charge 2 positive, except which one? Okay, so for A, you can see we have the S2P1, so that means this one will be from group 13. So group 13 will form positive 3 ion, right? Then for B, here you can see here we have the orbital D for B and C. So that means here B and C here will be they are the transition metal. So they have the possibility to form variable oxidation state. Okay, variable oxidation state. So that means they can be possible to form +2, +3 or others lah. Okay, because they have the orbital d here. So they have the high possibility to form different type of oxidation number. Okay, then here S2, so that means here this one will be for group 2 lah. So this one will be form only +2 oxidation state. So here which one will be not able to form 2 positive? So answer will be A lah. Huh? Okay, now let us continue our question number 5. Let us read the question together first. So the shape of the molecule and polyatomic ion could be determined using the VSEPR theory. Which species has the smallest bond angle? So for this question, you need to identify which compound of species here have the smallest bond angle. So you may draw the molecule shape for each compound here, so that you can identify the bond angle for each species here. So for A, beryllium chloride. So beryllium chloride will have the linear shape like this. Okay, so because the beryllium is from the group 2, so the bond will be probably like this. So this will be considered as a linear shape. So the linear shape, so the angle will be here to here will be 180. Then for the B, there is a boron fluoride here. So boron from the group 13. So the shape will be like this. So be trigonal plana here. So here will be 120. Okay. Then for the carbonate ion here, so carbon will have double bond. Okay, so will be like this. So here also trigonal plana for this species. So will be also 120. Then the last here will be the SO4 2- ion here. Okay, so here will be sulfur will be group 16. So we like this. Double bond here and double bond here. So this will be the shape of the tetrahedral. So the tetrahedral, so the angle will be 109.5 degrees. So from here, we are clear that the smallest bond angle here for the species A to D here will be D. So answer number 5 will be D. Number 6, a liquid which has a strong van der Waals forces show that it has high density. Okay, so because of the van der Waals forces is considered as a weak intermolecular forces, so that means the distance between two molecules will be far apart, because the attraction between two molecules will be less compared to other stronger intermolecular forces. So they will be far apart, so that means the density will be low. So the first one will be wrong already. So it's low. Okay, then for B, also the wrong, because the van der Waals forces normally is not equal to the strong covalent bond here. So second also wrong. Okay, and then the third, high solubility in water. That means that they will be forming for the hydrogen bond. So this is not possible for the van der Waals forces. So that means this one also wrong already. So the answer will be D. Okay, so high enthalpy of vaporization, so involve breaking of intermolecular forces. So strong van der Waals forces, so it will be involve high vaporization. So answer will be D. Okay, so at temperature T degrees Celsius and T ATM, 500 cm³ of unknown diatomic gas contains 7.50 times 10 power 22 molecule and has density 8.00 times 10 power -3 gram per cm³. So which statement is true about the gas? Okay, so firstly, here mentioned that this is a diatomic gas. So we have many examples. For example, we have the polar. So for a polar one, normally they will be involved two different elements. So example here we have the HCl. H will be more positive, negative will be for Cl. So that means the first statement, this one is polar molecule. But for the di molecule, we also can have non-polar one, where both elements involved have the same type. Example, we have O2 lah, we have F2, we have N2. So this type, this example will be considered as a non-polar diatomic gas. So that means the answer A is wrong already lah, because the diatomic gas here can referring to polar or non-polar. Okay, so answer A wrong. And then for the B, if we have as an ideal gas, so here we do not have any other data lah. So here this one will be considered not enough data lah. We're not sure. No data here. Then the electrode here also the same. We are not sure. So maybe correct lah, huh? So we go to D. We have to calculate for the atomic mass. Okay, so here you can see the question given us the numbers of molecule here is 7.5 times 10 power 22. So as we know that one more will be have 6.02 times 10 power 23 molecule. So from here we can get numbers of mole here. Numbers of mole for the diatomic gas here will be 7.5 times 10 power 22 divide 6.02 times 10 power 23. So we get 0.125 mole. Okay, so here also given another information, the density and also the volume, so that we can get the parameter mass here. So mass will be equal to density multiplied with the volume. So density here will be 8 times 500. So we get 4 grams. Okay, so from here, numbers of mole equal to mass divide relative atomic mass. So relative atomic mass will be, mass we find that will be 4 grams divided by numbers of mole, 0.125. So here will be 16. So that means we sure that the answer D will be correct already lah. Okay, so number 8. Okay, so which phase diagram is correct for water? Okay, so which one? So in atmospheric pressure, which is 1. So that means the water can be exist in 3 phase lah. Okay, must be, so that means that the first 1 atmospheric must be above the triple point lah, right? Above the triple point, that means that the liquid can be formed, can be exist in 3 different states in under atmospheric pressure lah, which is normal we find in Earth lah. So that means the A is wrong already, because the 1 atmospheric pressure here is below the triple point. So that means that in this case, they will be not possible for the water exist in gas state lah. So the first wrong already, and then here also the same, out already, A and D out already. And then the second, we have to observe the line here between solid and liquid. So we must choose the negative slope, because the water showing abnormality when under the cold condition. Okay, so because of these two factors, so the answer will be. Okay, so number 9, a reaction is represented by the following equation. So this one is the rate change of the concentration A lah. Okay, it will be x mole per dm cubed per second. So which statement is not true? Okay, so for the first one, rate of the reaction depends on the concentration, pressure, temperature, and catalyst. Okay, so that means that not depends on delta H here lah. Then B, the product is more stable than the reactants. Okay, so here, this one correct now. The first one, independence lah. So correct. So which one is wrong? So the statement here, you can see this is a positive enthalpy. So that means if let's say you draw the diagram here, so it'll be like this. So the reactants have lower energy, and then the product will have higher energy. So that means that here the reactants which has the less energy is more stable. So the answer here wrong already lah. Should be less stable lah. So answer is B lah. Then we go to C. The reverse reaction has lower activation energy, correct lah. So if let's say forward, so the E will be here. So the activation energy is higher. But when we reverse the reaction, so the E will be here, will be reduced lah. So that means that the reverse reaction will have a lower activation energy. So this statement also correct. Okay, so for statement D, so firstly we get this one lah, minus the A dt, we get X lah. And then for C and A, so 1 over C will be equal to minus 1 over A dA over dt, right? Okay, then we move the A to another side, we get A over C dt over dc over dt. So equal to negative dA over dt. So here will be X lah, right? This one will be X. So dC over dt will be Cx over A. So this statement also correct lah. Number 10, at 700 degrees Celsius, nitrogen monoxide and hydrogen react as follow. Okay, will be this equation. The initial concentration and the initial rate. Initial concentration will be here. Initial rate will be here. For the experiment as shown in the table below. Okay, so the first experiment will be this value, second, third, and fourth. So what is the initial rate? So the question asks, what is the initial rate when the concentration for NO and H2 change to 0.0060. So that means that we need to find out what is the rate equation for this reaction. Okay, so initially, okay, so we can form the equation on rate. So the rate will be NO, X, and H2, Y. So we need to identify what is the value X and Y here, right? Okay, because we don't know what is the order for the respective element here. Okay, so that means here we can using the information from the experiment to find out what is the order for the respective element here lah. So the firstly, you can look at the experiment 1 and 2. So the concentration for H2 is the same. So the increase for the concentration with the same concentration of the H2 here. So we increase 2 times from 1 to 2, right? Okay. So you can just write here for the first, the NO from experiment 1 and 2 So the concentration increased 2 times 0.04 divide 0.0020. So 2 times. So how about the rate, increasing rate here? So we're using these two values. So the rate here will be 0.013 divide 0.0033. So we get about 3.9. So which is closest to 4 times. So that means with 2 times increasing for concentration, so there will be 2 times increasing, 4 times increasing for the rate. So here we know that for the NO, here will be second order. So that means the Y will be 2 already okay? And then we need to identify, actually we know X is already, X is 2 already. Okay, then the next, we compare the experiment 3 and 4. So where the concentration for NO is the same. So from here you can see the rate increasing for the H2 also 2 times, 0.004 divide 0.0020. So also 2 times. So how about the rate? So for the rate here you can see also 2 0.04 divide 0.02. We get 2 times also. So that means here will be order 1 only first order. So from here we know that, so here go K. So the rate will be K NO. NO will be 2. H will be 1. But normally we write the first in front now. Okay, so we can get, here we have 2 ways to do. First way, we can eliminate K. How we eliminate K? So we can choose one of the experiment here. For example, we choose the first one. Okay. So the rate here is 0.0033. Okay. And all here is 0.02 square. And then for the H2 will be 0.012. So this will be first equation. The second, the question asks us to find out the initial rate. We can given that the rate is X. So the X will be equal to K. And then the NO here, 0.006. And then for the H here also 0.006. So we're using 2 divide 1. So we get X over 0.0033 equal to K 0.0060. So here can be Q, right? So divide K 0.0020 square and 0.012. So we can cancel out K. So rearrange the formula, you can get X will be 1.5. Answer will be A. Okay. Actually, you can using one of the equation to find out the value K. Okay, then you substitute again the value 0.0060 for the respective NO and H2. So again, you'll get the answer closest to 1.5 also. Okay, so number 11, the equation for the reaction between P and Q is shown below. Okay, so 2P plus Q produce R. So the rate of reaction increased 8 times. Rate of reaction increased 8 times when the concentration P and Q were double. So that means the P concentration changed to 2P, Q changed to 2Q Okay. So again, for this question, we need to find out the order of reaction also using the same method which you learned in question number 10 here. Okay. So again, we can write down. Okay, so we can write down the equation. So the rate here will be K, P, and Q. but P is X lah, Y is Q. Okay, so this one, we can give an unknown for this equation will be Z lah. So this is the first one. So for the new reaction, new rate, the K will be 2P X 2Q Y. Okay, for the new reaction here lah. So from here, we can expand. We know that the index for 2 will be X. Here will be PX. Here, 2Y and QY. So we take out the 2X, 2Y. So we get KPX, QY. So from the equation 1, here will be equal to Z lah. So here will be Z. 2X plus Y, Z. So from the question given us, the rate of the reaction increased 8 times. So just now we know that the rate will be Z already. So the new reaction will be 8 times Z lah. So be XZ. So we cancel out. So we get 2Q equal to X plus Y. So from here we know S plus Y equal to 3. So here will be third order lah. Okay, so the numbers of correction increase 8 times. This one will be also not sure, because we know that every effective correction will be have the product will be produced lah. Okay, so this one maybe will be higher than 8 lah. This is the minimum lah. So we're not sure, so this one will be wrong. Okay, then the C, average molecule speed of the P and Q increase 8 times. So the speed of the molecule will be dependent on the temperature. So as the temperature increases, the speed, average speed of the molecule will be increased. So here no mention any increasing of the temperature, just mention that the concentration is double up. So that means here no mention temperature. So this one also not correct. Okay, and then the D, for the D, second order for the Q, and for the P, this one we're not sure, because we know that these two will be have the third order. So that means the possibility for the rate will be maybe all depends on the P. So that means that the Q, the P maybe is 3, not second order. Okay, or the rate can be also P square Q. So this one also considered is third order, right? This one statement is correct lah, but this one also not cover for all rate lah here, because the P may be 3, not second order. Maybe it's third order lah. Okay, maybe the P can be 1, first order, Q is second order, or the P can be 0 order, and then Q is third order. So the D also the wrong lah, also wrong already. So answer, the best answer here will be A. Okay, so the Haber process for synthesis of ammonia involves the following reaction. Okay, so what is the true for the reaction at equilibrium? Okay, so for this one, the first one, Kc and Kp will be equal if the numbers of mole involved is the same for the reactants and the product. So here, the mole involved for the reactant will be 4. 1 plus 3, but here, the product will be 2. So that means the Kc and Kp will be not equal lah. Okay, so wrong already. Then the second, the K1 and K reverse. Okay, so for the B, K1 and the K reverse lah, so be equal. This one will be only for 0 enthalpy H lah, reaction here. So here also no mention. So this one also wrong. Okay, so this one will be the answer. So because this Kc equal to this ratio will be correct for all reversible reaction. Okay, and then the last one will be wrong also lah. Okay, so number 13. Okay, so the equilibrium constant of two equilibrium systems are as follow. Okay, so the first one. So here we have two equilibrium equation here lah. So for the first one, NH2OH is stronger acid compared to H2O. Okay, so we have to see second equation here. So A compare this NH2OH together with water. So from here, you can see the product. The hydrogen will be accepted by NH2OH here. Okay, so this one will be base lah. So this will be acid. So here mentioned NH2OH is an acid, so it's wrong already lah. And then for the B, CH3 2NH will be here. Is stronger than OH minus. Okay, so from here, you can look at the value Kb here. So the value Kb minus 4. So that means this is the small value of Kb. So that means small value of Kb, the equation will be shift to the left. Because the product is less compared to the reactants here. Okay, so it will be shift to the left. So that means here, the OH minus is stronger lah, compared to the CH3 2NH here. So this statement also wrong already lah. Okay. Okay, and then for the C, the question asks us to compare. NH2OH will be here, and CH3 2NH will be here. Okay, so we compare both of these, which will be a stronger base lah. So from the Kb here, you can see that the first equation here, the Kb value is higher compared to the second one. So that means the reaction for number 1 will be more easier to occur lah. So that means the CH3 2NH will be stronger compared to the bottom one. So this statement also wrong already lah. Or we compare the Kb value. Okay, and then for the last one, actually you have many ways to think about the statement here. Actually, the acid can be reverse observation for Kb lah. So since you can compare the Kb value here, the first one is bigger compared to the second one. So that means the second one, the reaction will be more easy, shift to the left. So that means this will be strong acid lah, stronger acid compared to the first one lah. Okay, so answer will be D. Or you can actually calculate Ka lah. So Ka will be using formula Kw divide Kb. So you will get that the value for Ka for second equilibrium here will be higher lah actually. So you have two ways to think lah. You can think reverse value for Kb, or you can calculate Ka. So the Ka for the second equation here must be higher lah. So showing that NH3OH will be stronger acid compared to the above one. Okay. Okay, so we go to the 14. Okay, so compare X is a weak acid. Titration of the 10 cm3 1.0 mole dm3 of solution X require 20 cm3 of 1.0 mole dm3 NaOH solution for complete neutralization. Okay, so here you can see our reaction is between the weak acid together with the strong acid. So for sure that the pH value at the end point will be more than 7. So the statement 1 wrong already lah. Okay, and then the compound X is a monobasic acid. This one we need to find out. Okay, so we need to find out. So for the first, we need to find out the numbers of mole for the NaOH. Okay, so here 20. 20 cm cube per 1 mole. So we are using 20 divided 1000 and 1 mole per dm cube lah. So you'll get this one will be equal to 2.0 times 10 power negative 2 mole. Second, we find out the numbers of mole for the weight acid here. Okay, weight acid compound X here lah. So here will be 10 divided 1000 times 1 lah, 1.0 here. So you'll get 1.0 times 10 power negative 2. So if we divide ratio mole X to mole NaOH, so we will get 1 to 2. So that means here X will be dibasic acid, not mono lah. So this one wrong already lah. So we need to compare the numbers of mole between X and the NaOH lah. Okay, and then the second, the C. Okay, C we already know the reaction is between weak acid together with a strong base. So the end point will be greater than 7, which is at the alkaline range. So that means we're using the phenolphthalein lah, because we know that the range measurement for the phenolphthalein will be between 9 to 11. So answer here will be actually C lah. Okay, and then the D also wrong, because the bubble solution referring to the acid S, weak acid together with the conjugate base lah. So here no mention any conjugate base lah. Okay, because the base here we're using NaOH actually is the excess already. So the answer is C. 15, the pH value. The pH of the saturated solution calcium hydroxide is 12.4 at the temperature 25 degrees Celsius. What is the value of solubility product gas P for calcium hydroxide? Okay, so we need to give the equation first lah. The calcium hydroxide will be dissociate, become calcium and OH. So here you can see, to balance the equation, here will be 2 mole of the hydroxide ion produced lah. Okay, so we need to find out the solubility. So let's say the solubility for the calcium hydroxide is X. So here X, here will be 2X, right? Okay, so question given us pH will be 12.4. So pOH will be 14 minus 12.4. So you get 1.6. Okay, so we get concentration of OH will be using this formula log, negative log concentration of the hydroxide ion equal to 1.6 lah. Okay, so the concentration for the hydroxide ion will be 0.025 mole per dm cube. Okay, so from the equation here, you can see that 2 mole of the hydroxide will be involved 1 mole of the calcium ion. So that means the concentration for the calcium ion will be half of the 0.025. So we get 0.0125. Okay, so for KSP, the equation will be calcium and OH minus square because of this lah. So calcium will be 0.0125. Then for the hydroxide ion here will be 0.025 square. So we get the answer here 7.81 times 10 power minus 6 mole cube. So answer will be A. Okay, so that's all for discussion. Okay, 指挥哦。OK 啊，拜拜。
拜拜，老师。